All right, let's go ahead and get started. So real quickly, let's try and remember what we talked about last time, since we ran through so much material and you're probably completely confused and don't remember a single thing of it. But let's at least highlight the one thing you really need to get from it in order to pass this course. Good morning. Which are these K-maps. And so we did a 3-variable K-map. And let's go ahead and draw that on the board. And by us, I mean me. Good, good. So we'll have X here, and this of course will be X naught. We'll have, what do we have, Y up here. And this will be Y naught. And then we'll have this come down, and this can be Z, and this can be Z naught, and this can be Z naught. All right. So real quickly before we begin, let's see how many remember what. Good morning. So remember, we are going to write in our min terms. Min terms means it's seeking the minimum, so it's the anding. Each term is a bunch of and of everything. And the number will represent in bits which ones are, I guess, normal or not complemented. In other words, 0 means complemented and 1 means normal or not complemented, whichever you prefer. So in this square, you have not X, not Y, and not Z, and that pertains to the bit value 0, 0, 0. So this one is, of course, 0, or if you prefer, you can call it M sub 0. All right, what's this one? The bits value here, X is the first one, Y is the second, and Z is the third.
0, 0, 1.
0, 0, 1, so it's M sub. I'm not trying to be tricky, just want to make sure everyone's on the same track. All right, how about this one over here?
0, 1, 1.
And that's M sub. Perfect. How about over here?
0, 1, 0.
0, 1, 0. M sub 2. All right. How about this guy over here?
1, 0, 0.
1, 0, 0. M sub 4. How about this one right here?
1, 0.
1, 0, 1. M sub
5.
5. Yep. And this one?
1,
1, 1, 1. M sub
7.
7. All right. And then we have 1, 1, 0, and that has to be M sub
6.
All right. Hopefully that was a good review, because we're going to take this to the next level of doing 4-variable and start the analysis. So we wish to simplify this basic equation or circuit. We went through a lot of definitions and terms last time to prove that basically any circuit can be written out as the sum of midterms, hence the sigma m. And 1, 2, 3, 4, 5 signifies which blocks inside of your K-map are going to be 1. And so if you actually write that down, so 1, 2, 3, 5, 7. There they are up there. And so if we want to look at this and we want to simplify it, how can we simplify it? Well, first, let me help you all out. You want to choose the largest block you can create, which happens to be this one. And since it's 4, that covers 4 squares in an 8-square K-map, that means it's Z, but we still have a 1 over here. So we want to OR it with something on this side. We could OR it with, not X, Y, not Z, but we can also enlarge the box to include this guy over here, which will turn it into not X and Y. And so this is a way, from at least K-map and looking at it, you can come up with an optimal circuit just by reviewing the K-map. All right, how we doing? We're going to do a lot more of these. Hey, look, let's do this version. We'll just write it up here. So 0, 1, 2, 4, 6, 7. Whoops. 7. Oh, I think we did this last class.
So,
So what's the optimal here?
not Z.
Not Z. Remember, that's these two guys over here. Let me go to these two guys up here. And then
Not X.
not, wait. Okay, I'll help you out. YZ for this box right here. And then we still need to get this guy, and we can use this whole box, which is
Not X, not Y.
not X, not Y. All right. Hopefully that was mostly a review. Now let's go to the for version, because that's where this technique starts to become really helpful. But before we go to the for version, you have to understand how the for version is created, which does get kind of weird. And so we have what? Y, or W, sorry. And then we're going to have X in the middle, all right. Bless you. And let's see, we're going to have Y up here. Hey, look, that's 3 variables right there. Just kind of flip the other way. Bless you again.
Thank you.
And then we'll do the Z. Okay. All right. Let's fill this in. What's the bitmap here?
0, 0, 0, 2.
0, 0, 0, 0. So it's M sub 0. This one?
0, 0, 0.
Nice. Now wait a minute. Oh, Matt said it, but you perfectly mouthed at the same time. I was so confused because Matt was right behind you. I was like, what just happened in life? All right, what is this one?
That's
Hmm?
fun.
What? All right, how about this guy?
That'd be 0, 0, 1, 1, 3.
This guy?
0, 0, 1, 0,
0, 0, 1, 0. Right, and then the number is 4. I tracked. I was following you.
4. Well, that should be 2, shouldn't it?
You are correct. I just agreed with you. Whew, man, that was bad. All right, how about this over here?
Let's see.
Remember, it goes W first, and W is off, so that's a 0.
1,
Then it goes to
0,
X,
1,
X is on, so that's a 1. Then it goes to Y, Y is off, so that's a 0. Then it goes to Z, and Z is off, so that's a 0. Yes.
Sorry, I know we did this last class, but could you show me how to do the bitmap again?
So we're doing min terms.
Mhm.
So a 0 means you're on the complement, and 1 means you're on the regular. So in this square, and it goes W, X, Y, Z.
Yeah.
W is complemented, so it's a 0. Next is X. X is normal, so that has to be a 1.
Gotcha.
Y is complemented, so it has to be a 0. And then last one is Z, and it's complemented, so that has to be a 0. And that number is 4.
Now where does that number come from?
This is the bit representation of 4.
Gotcha.
Because this is 1, 2, 4. All right, next.
0, 1, 0, 1.
Oh, yeah. And that number is,
5.
all right, next.
0, 1, 1, 1.
0, 1, 1, 1, and that number is,
7.
hey, this should look familiar. And the last one,
0, 1, 0, 1, 0.
1, 0, thank you. And that number is,
6.
okay, great. Now for the new ground, where things might get a little tricky, so just hang on. What's this one?
8.
The bit.
1, 0, 0, 0. Is 1,
No,
2.
wait.
Oh, wait.
No, X is on. So it's 1, 1, 0, 0, which is 12. Like I said, it's a little tricky. It's okay. It's all right. It's all right. How about this one?
The one to the right of the one we just filled in?
This one right here.
Okay.
1101.
Spoiler alert. It's this row with a 1 in front of it. What number?
13.
How about this one? This row, but that's flipped to a 1. So the number is 15. Whoops. Because at this point, hopefully you've seen the pattern. When you move one block, you're always flipping a bit, just one bit. And in this case, you're going from the top and you're adding, and you're changing the leading one to a 1. That's the flip. And then, so this number is 14. Okay. All right. How about this guy?
Is that one
18000?
Yeah. 1000, which is not 1,000. It is
8?
this one.
1001.
Now we're just taking that X bit and turning it to off. And that number is this one.
Oh, no. That one was 1011.
Yep. And that number is
811.
811?
11.
11. It's like 811. I'm not familiar with that number. And the last one.
1110.
No.
1010.
Yeah. And that number is 10. All right. I went through that the long way so you could see how it comes, how you arrive at each of those numbers. You can either remember how that's done or just take your sheet of paper, copy these numbers down in this on this grid, and just be happy that that's the way life is. Whichever works best for you. I know which one you're going to choose, Holland, and that's okay. I'm good. I'm actually perfectly fine with it. So, or you can just memorize that this is how it looks and write it down and copy and paste or copy pasta that a lot, and you're good. All right, 4 variables. So if you have a single one, that equates to 4 variables. All right, when I say a single one, that means if you highlight one box, that equates to a term with all 4 symbols in it. For example, this one is not Y, not X, not W, not X, not Y, not Z. This one over here would be, let's see, that would be, not X, Y, and then should be, I'm sorry, it's W, not X, Y, not Z. There we go. So it's all 4. On the other hand, if you have 2 of them, aka right next to each other, like right here, that's going to equate to 3 variables. And in this case, what's that going to be? That's a great question. Isn't that X, Y, and Z naught? So we remove the W because we don't care, because it highlights both of them. If you have 4 of them, which makes a square or a column, that will equate to 2 terms. So if it's this column right here, that will be Z naught, and what's the other one on this one? Z naught Y, correct, Z naught Y is this one. If you create a box like right here, that's going to be, what's that be, XY, because it's this box right here, and then we don't care about Z or W. And then if you have 8 ones, so you're taking up like this entire thing, it's 1 variable, it's Y, and you don't care about what the other ones are. And of course, if it's 16 ones and you've taken up the entire box, then the answer is 1. All right. A little confusing? Sure, let's go look at pictures. What's that box?
That is
ZX, or XZ, if you wish to say alphabetical. How about that one?
Why not?
Not W, Y.
Yeah, not W and Y. Not W and Y because it's up here, and that's not W. The knots are, the complements are not displayed, there we go, on this graphic. So if you notice that this is not W and then this is Y up here, it's covering these 4 slots, and we don't care if X is normal or complement, it's irrelevant. Same thing with Z, we don't care if it's normal or complemented, it's irrelevant. The boxes here are not W and Y. Oops. All right, keep in mind the corners exist. This is one that can throw students off. What are the corners here?
Z not, or not Z.
And
Not Z.
not, it's, yeah, so it's not X and not Z. The other way you can think of it is, well, you don't have Z and you don't have X, so it's a complement, not X, not Z, if that helps. If what I said was confusing, ignore it. Just pick whatever I tell you that makes sense and ignore what I'm saying afterwards. And, well, that's a giant mess. Oh, wow. That's terrible. Well, that didn't help you. Oh, well. All right, 4 variable simplification. Let's use green. So, did I break my chalk? No. All right, good. So, 0, 2, 4, 5, 6, 7, 8, 10, 13, and 15. All right. I wonder how easy that is to see. On the screen, it doesn't look like. By the way, that is a different color. Sure. All right. How do we simplify this? Well, we got a big, nice box right here in the middle.
Yeah.
Now, how am I seeing these boxes? Let me at least tell you a systematic way to get to these boxes so it helps you out. Pick a square. Any square. Doesn't matter. Let's pick this square. Is that the smallest square you can make with this one box? No. You can make a bigger square. You can make this square. Great. So we look at these two. Is this the smallest or the largest box you can create with those 2 blocks in it? No. We can make a box like this. All right, we have a box that's this big. Can we make a bigger one with those 4 in it? No. So, first step is finding the largest boxes you can create with every variable. And in this case, we have this one right here. So let's start with that one. What is this middle box right here? Z. Yep. It's Z and actually it's ZX. Yeah, or XZ. Let me make that little. All right. So we'll check, 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 check. All right, let's pick a box that we haven't chosen yet. And let's do this one. And of course, it does matter which direction you go. But in this case, let's go this way. And you'll see in a moment a more systematic way to do it. But I'm just going to tell you right now. Take this one, go to the left. Now you have 2 boxes. Is that the biggest one you can make? No, you can make this whole row right here. And is that the biggest you can make with those 4 boxes? Yes. So, what is this row right here? Not WX is what I got as well. Because we don't care about the Z's and we don't care about the W's. Yep. All right, we're going to this box. Again, I'm going to help you out. Don't go down. You can actually go here and over here and have those 2 corners. But is that the biggest? No, because you can also add these two corners. So what are the four corners?
Not zero.
Yes, not x, not z. And then we got the corners as well. Let me erase my numbers real quick, because I want to reuse this and not rewrite it again.
Is it possible to have more than last year? If it doesn't-
Yes. Yeah. Good observation. You want to do it again?
To be honest, yeah.
Okay, that's fine. That is why I asked.
Just for clarity, the Y's are the two center columns, right?
The y's are on the side, so or regular y's over here, complemented y's on this side. Hence y and not y.
So why would the corners be just not X and not Z?
So not x restricts you to these columns, right, or these rows, right? Not z restricts you to these columns.
Yeah.
The intersection are the four corners.
Okay, why do you have corners? Okay, so you're going with the shortest or the smallest. I guess. Kind of. Yeah, okay.
All right, we'll do this one. So we got 3, 4, 5, or 7. 7, 9, 13, 14, 15. Oh yeah, this one's going to be messier. A little more straightforward.
We have ZX for XZ.
Yep, we got XZ. So the biggest one's in the middle, and that one's straight up XZ. Because Z restricts you to this column, these two columns. X restricts you to these two rows. Their intersection are these four blocks. So by choosing XY, we have this one, this one, this one, and this one. All right. Well, this is going to be amusing. Let's do this guy. You see the smallest? Is that the smallest rectangle, I should say, that you can make with that one square?
Yeah.
You can make this one too. So you can include this guy below it. So these two, is that the smallest rectangle you can make with those two squares? That is legal, actually. Yes, I mean, because you can't have 3. You have to have 1, 2, 4, 8, or 16, because it has to be able to intersect. So if we're going to do these two right here, what do we care? Well, we want to restrict it to these columns, so that'd be y. We can't choose x because it splits x. So we're not choosing x, we choose y. And then we're going to choose z as well, so restricts to those two. And then we need to choose not w to restrict it down to that. Not w, y, z. And that chooses this one and that one. Yes.
Why do you choose blocks you've already chosen before?
So if I didn't choose this block, then the value down here would have an x naught in it, and that would be an additional AND gate and an additional literal, which would cost more in the final circuit. But it's not required because we're already selecting that one. You can select it as many times as you want, doesn't matter. And we want to simplify or make the circuit as small as possible. Okay, what's next? We'll do this one. Can we grow that?
Yeah.
Yeah, we can grow it over here to these two. Can we grow it anymore? No. All right, what's that one?
Not W, not Y.
Not W, not Y. Let's see, not W, not Y would be these four right here.
And also be X.
X. So we do need X in front of it. Oh. There we go. Not W is right here. I mean, not W is these 8. Not Y are these, so we've got it down to these 4. but we need to have X choose these two. We don't care about Z because we're selecting across Z, so that's why it's ignored. All right, let's do this one. We choose this box. Can it be bigger? Yes, we can grow it to 2, but we can't grow it to 4 in either direction, so we're stuck with those two. So what's this one going to be? So we have W, yep, selecting all 8 of those, X, which is selecting this row, and then Y, which selects this column. Beautiful. And then lastly is that. Right here, can we grow it? Yes, we can grow it to these two, but we can't grow it anymore. So what are these two boxes right here? Let's start with W. W, not Y, and Z. We don't have an X because it splits. That's why it's not here. All right, how's that? Yes.
So when writing it, does the order of the knots, like the knots and the regulars, does that matter?
You mean down here?
Yeah, like if you.
By convention, please write it from alphabetical order.
Okay.
That's just convention. I mean, and has the associative property, so you can rearrange it and still be correct. Please make my life easier. All right. Okay. All right, so we talked about how we can do it. Let's go